It has taken more than 4 billion years for intelligent life to emerge by natural selection on Earth. But there are billions more years ahead in our planet's lifetime. Over that time, intelligence could develop in entirely new directions. Many assume that human beings are the peak of intelligence, but it is possible that our species may represent a stage on a path towards minds that are more artificial. This could explain why the cosmos seems so empty of life like us. If an evolutionary transition to non-organic intelligence is inevitable across the universe, our telescopes would be most unlikely to catch human-like intelligence in the sliver of time when it was still embodied in that form. It is perhaps more likely that the aliens would be the remote electronic progeny of other organic creatures that existed long ago. The prospect of inorganic alien intelligence raises some striking possibilities. If these beings are out there, they would act and think totally differently to us. For one, non-organic intelligence may have no use for an atmosphere, or the planet on which they originated. Interstellar voyages, or even intergalactic voyages, would hold no terrors for near immortals. Indeed, they may prefer to live in zero gravity, because there you can make very large and lightweight objects. If you wanted to build a huge, elaborate, gossamer-thin structure to harvest energy, for example, it's easier in space than on a planet. It's also not obvious that they would need to live in orbit around a star. Perhaps they'd have new ways of getting energy that we just can't envisage yet. If they have silicon-based brains, they might realize that the energy needed for processing bits is less at low temperatures. So, they would expend less energy in colder regions away from planetary systems. They might even choose to hibernate for billions of years until the cosmic microwave background, the leftover radiation from the Big Bang, is further cooled by the continuing expansion of the universe. Silicon-based life. On Earth, life is based on organic compounds. These molecules are composed of carbon and often include other elements, such as hydrogen, oxygen, nitrogen, phosphorus, and sulfur. However, scientists have long wondered if alien life might evolve based on significantly different chemistry. For example, researchers have long speculated that silicon might also serve as a backbone for biology. All living things that we know about have some basic things in common. They grow, reproduce, respond to stimuli in their environment, and evolve over time. They also all share the same basic biochemistry. They're made out of long chains of carbon molecules that hang out in a water-based medium. But it's also possible that there's life that's not carbon-based, and it would be a lot different from what we're used to. Carbon's ability to form long chains makes it the perfect base for building molecules complex enough to keep a living thing alive. Even though carbon is great for building these big, complicated molecules, it's not the only element that can do this. Silicon, which sits just under carbon on the periodic table, shares many of the same chemical properties. Just like carbon, the outer layer of a silicon atom has 4 unpaired electrons ready to form molecule-building bonds. Silicon is the second most common element in the Earth's crust after oxygen, but that silicon is bound up in rocks, where it will be hard for organisms to incorporate it into their biochemistry. If silicon life does exist on Earth, it might be in the form of silicon-based microbes living within magma deep inside the Earth's mantle. Researchers have long speculated that alien life could have a completely different chemical basis than life on Earth. For example, instead of relying on water as the solvent in which biological molecules operate, perhaps aliens might depend on ammonia or methane. And instead of relying on carbon to create the molecules of life, perhaps aliens could use silicon. Scientists have long known that life on Earth is capable of chemically manipulating silicon. For instance, microscopic particles of silicon dioxide, called phytoliths, have been found in grasses and other plants. And photosynthetic algae known as diatoms incorporate silicon dioxide into their skeletons. However, there are no known natural instances of life on Earth combining silicon and carbon together into molecules. The Fermi Paradox. Given that our solar system is quite young compared to the rest of the universe, roughly 4.5 billion years old compared to 13.8 billion, and that interstellar travel might be fairly easy to achieve given enough time, from Nobel Prize-winning physicist Enrico Fermi, who supposedly made the above points during a casual lunchtime conversation in 1950. And the implications have had astrobiologists and other scientists scratching their heads in the decades since. This paradox was described by the late British science fiction author Sir Arthur Charles Clarke, who said, "Two possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying." Many experts since have grappled with the same question. Why, considering the multitude of planets and stars in the Milky Way, have we not heard from anyone? We call this problem the Fermi Paradox, and there are a number of possible solutions, some more unnerving than others. According to NASA, in just the last 2 decades, we have found more than 4,000 planets beyond our solar system, with trillions of stars thought to exist in our galaxy, most of which host their own planets. Considering life sprang up on Earth, would we not have expected it to start in at least one other location in the last 14 billion years of the universe? There are a number of solutions to the Fermi Paradox. The most likely is that we simply have not looked hard enough to find other life, and interstellar travel between stars is difficult. The first planets beyond our own solar system were only discovered in the 1990s. This means we have barely started to scratch the surface of studying other worlds. We are yet to find many planets that look exactly like Earth, orbiting stars like our Sun, but upcoming telescopes are hoped to be capable of such detections in the coming decade or two. Even then, the distances between star systems are enormous, making journeys between them difficult. Our closest star system, for example, Alpha Centauri, is 4 light-years away. The distance from Earth to Neptune in comparison is 0.0005 light-years, a journey that would still take us decades with current technology. Intelligent aliens might simply have decided to never visit us, or did so long ago without leaving any trace. Alternatively, it might be that life is simply so rare that the chances of 2 intelligent species being positioned relatively near each other in the vastness of space is exceedingly slim. A more sober suggestion is that we are alone in the universe. Life, like that found on Earth, is simply so vanishingly unlikely to arise that ours was the only world where this happened. Most scientists think this is unlikely, but there is the possibility that some sort of event, known as a great filter, might prevent civilizations like our own from progressing far enough to make contact elsewhere. Alien language. You can learn a lot about an animal by how it communicates. Birds tweet melodies to attract mates and defend their territory. Dogs befriend each other with wagging tails and smelly pheromones. Even plants communicate by diffusing chemicals through the soil, networking with the root systems of the flora around them. So, what if we do discover life on another planet? And if it turns out to be intelligent, how might we communicate with our cosmic neighbors? Humans have a long history of bridging seemingly impossible language barriers. Researchers who decipher ancient scripts and languages use shared human habits as a reference point. For example, the way we might circle something important in writing helped scholars unlock the Rosetta Stone, a decree that dates to 196 BC that provided a clue to reading ancient Egyptian hieroglyphs. Body language is also an important tool. When the Spanish conquistadors arrived in the Americas, for example, they used hand signs and gestures to communicate with the indigenous people they met. Extraterrestrial beings may think and behave in a completely different way to us. Their social structure, if they have one, could be totally unrecognizable or even unfathomable. So, how could we guess what they might be trying to say? Eric Kirschenbaum, a behavioral ecologist at the University of Cambridge, UK, believes that evolutionary challenges are truly universal, and that the evolutionary forces that shaped life on Earth will produce many similar features in extraterrestrial life. If he is correct, it would mean life and language throughout the cosmos may share certain features.